Is that working? Good evening, everyone. Gosh, that was very, very, very well observed. The room fell silent very quickly. Delighted to be here for the James Clayton Prestige Lecture, which is on understanding, measuring and sustaining a resilient water system. It is also really fantastic to see so many of you in the room. Many of you have been here all day, I know. I'd like to give a particular warm welcome to the member of council members and observers who travelled, some of you from really quite far to be here today. We had a fantastic council meeting today. I have to say it was really, really constructive. Lots of things now getting ticked off, moving forward. So it's a real pleasure to be able to also enjoy this evening and spend some time networking together this evening. Similarly, I'd like to thank the members of the Nominations Committee that are here in attendance. NOMCO have a meeting tomorrow, and I'm delighted that some of you were able to take the opportunity to come here and enjoy the lecture this evening too. And representatives of our Climate Change Adaptation and Resilience Advisory Board, who for the first time met this afternoon. And it's very appropriate to give a particular shout out to Dr. Tim Fox, Dr. Carola Koenig and Ruth Shilston, who were at that meeting this afternoon. So I am sure it was a very productive meeting. I'm delighted that you were able to stay on for the event this evening. And finally, we are global, we are inclusive, we are digitally enabled, and I'm very pleased to also welcome Thomas Kiefer, who I was chatting to earlier, and now I can't see, but there he is, fantastic. Thomas, who has travelled from Germany this week to represent VDI at our advisory board. We have an established collaboration with VDI in Germany. There's some really productive discussions now starting, particularly around our policy priorities. So we're particularly pleased that you're able to join us this evening. I'll finally say welcome to our audience online. So this is a hybrid lecture, and I hope that people will enjoy joining us this evening, but also enjoying the opportunity to watch the lecture later on. Now, at this point, it falls to me to introduce our first speaker. And we had to do a quick edit to the introductions here because as of 9 a.m. this morning, I would be introducing Dr. Mijic. I've just learnt that I'm now introducing Professor Mijic. Yay! Absolutely! And quite right, you should get some spontaneous applause. I said to Anna earlier, hopefully we will help make this day more memorable than it must be already for her. We also talked about the fact that she's peaked too soon, so my goodness, where's she going to go next? But many, many congratulations from all of us. We're absolutely delighted that you've chose to celebrate with us this evening. So Professor Anna is a reader in water systems integration in the Department of Civil and Environmental Engineering at Imperial College. Anna's research is at the forefront of advancing systems approaches to water management. She works on developing the methods and tools to tackle the intricate complexity of water systems, and the work is underpinned by the water systems integration concept, defined as coordinating human water needs and protecting water from water-related impacts while minimizing pollution and environmental degradation. So very much in line again with one of our key policy priorities around sustainability. Absolutely delighted to have you here with us tonight, Anna. Please join the stage. The floor is yours.
Thank you so much for the introduction. Thanks for having me. Thanks for congratulations. I am quite excited, which may translate into this presentation. But I'm very happy to be here and quite excited to talk about the audience, which is not my usual audience. I am a civil engineer, but I think considering the challenges in current society related to water and infrastructure, I hope you'll enjoy maybe the next around half an hour. And the talk is titled Understanding, Measuring and Sustaining Resilient water systems, and I'm gonna unpack this a bit. It is a lecture. So what I'll thought doing at the beginning is just to set the scene. So to set your mind on maybe the key things to notice in the presentation. You will see lots of information. But to get you through that a bit more easily, I'm going to do the talk by the keywords in the title. So we're going to do the presentation in 4 parts, and we're going to talk about the understanding, then what we in our research mean by resilience. I know resilience has many, many definitions. We'll talk about the measuring, which is the core of what we do. So we are modelers, so we measure the things by modeling them. And I'll finish with what we mean by sustaining is sustaining in the context of sustainable development, but sustaining in the context of resilience as well. Then I chose this. So this is the book that I read quite a few years ago now, but this is the book that introduced me to systems theory and systems thinking. It's a book by Donella Meadows. It's called Thinking in Systems. And if you haven't read it, it's a warm recommendation. You can download the PDF online for free. It's a beautiful book where she explains the basic of the systems thinking and then how that translates to environmental problems. And it really made me think completely differently about the water science, and everything you'll see today has some links with the theory she is explaining. And you will see at the top of the slides, you will see some quotes which I took from the book, which I think apply very nicely to what I'll be talking about today. And then the final thing, you will see purple boxes and you will see some blue boxes. And if there's anything I would like you to remember from today is the text there. So this is the key messages that I hope to communicate this evening. Okay, so we're going to start, and we're going to start with understanding. And with understanding, what I will introduce is at least what we in our research group see as a systems thinking in water management. And here comes the first quote. And in her book, Donella Meadows says that we think that because we understand one and we understand two, then we can understand both. But what we very often forget, that we have to understand and. And this is really where the key thing for us is that and in water management. So if you study civil engineering, then that's what I did when I was an undergraduate. We would learn about the natural environment, so we would learn about the river systems, hydrology, groundwater systems. It's where all our resources are coming from. And then we would learn about the supply infrastructure. So we take the water, we give that water to people in the cities, to agricultural systems, and so on. And then we would learn about different demand profiles, how people use water, how much water is needed, and so on. And then we also learned about the wastewater system, so that water then from households, from any use, has to go back somewhere. Sometimes we treat it, sometimes we don't. But fundamentally, that water ends up in the environment. And the link between these very high-level 4 subsystems is fundamentally what I'm interested in. So I would argue we have a really good knowledge about the individual systems. We have models for the individual systems, but what happens at the interface between the systems is still a big research question, but I would also say really big implementation question. And this is what we call integrated water system. You will hear me saying that word a lot. So by integrated water system, I mean the system that physically and operationally is connected in reality. Okay, so part 2 is what we mean by resilience. So what you probably know from the normal or kind of usual definition of resilience is what if we are resilient, we can react to stress and we can recover after stress. What is really important to note here, and where I'm going to start my argument, is that for integrated, for complex system, resilience really is about understanding what is very difficult to control. And my next quote, which I took from the book, which I really like, it says that we can't impose our will upon a system. We can listen to what the system tells us and discover how its properties and our values can work together to bring forth something much better that could ever be produced by our will alone. And from that perspective, so if we go back to the notion of the integrated water system, our values normally for most people would be in this part here, so in the people, land and water part. We are self-centric quite a lot. We want water for our needs. We are producing lots of wastewater we want to develop. But all that, of course, has the environmental footprint. So the purpose of the water system could be, and it is quite human-centric. But of course, then the other thing and the biggest other stressor which impacts our resilience is, of course, the climate change. And I won't talk about the climate change tonight, but for us, if we think about the water system, so any change in temperature, any change in precipitation patterns is a stress to the water system. But of course, these two stresses also interact. So when we add that, we start creating even more complex networks of different pressures. So when we think about the resilience, we can think about, for example, a loop like this. So we have the development, lots of human activities. We emit CO2, climate changes. We get lots of dry periods, less water in our rivers, which affects the water supply. And this is the reality. This is not something that we are expected to happen. It's already happening. And you will also see some articles from my usual news outlet, which is BBC, where these things are mentioned quite frequently. So this is the news from 2023 about the water shortages and hosepipe bans. So the first level of alert that water companies are implementing when there is water shortage. So from the perspective of resilience, if I'm managing water systems, I would be worried about the very long dry periods, so resilience to the low flow in the rivers, or low groundwater levels, depending on where the water is coming from. Okay, but then I can also redo my diagram, and I can then say, okay, but what happens if, because of the climate change, I go into another extreme? If I have very high intensity rainfall, so what if that flooding happens? What if combined sewer overflows happen? So then we get another problem of extremes and how the system reacts to both flooding, but also pollution. And from the resilience perspective, in a different climatic conditions, I am worried also about the high flows and the pollution. And the news I've chosen here is something that I'm sure everyone knows, because it's been in the media a lot in the last couple of years, which is the huge problem with the combined sewer overflows and the spills, which happen outside the regulation limits and have potentially the impact on river water quality. So from the resilience perspective, I would argue that these interactions in the water system, but also interactions around the drivers of change, are really important, and they need to guide our understanding and our measurement of the resilience, but also then the planning for the adaptation strategies. And in a similar way, as I'm talking about the integrated water systems, I will also talk about the systems level resilience. And in the next couple of minutes, I'll explain what I mean by that. Okay, so we finished with the theory. So now we're going to go a bit more into quantitative side. I've been told that mechanical engineers like details, so we're going to go into details a bit, and we're going to see some data as well. The measuring part. So from the measuring perspective, what I like to think about, so when we have the integrated water system, what we want to measure is how the water and the pollution moves through that system, which gives us dynamics, it gives us a time series of different performance measures. If we are looking at, for example, the water supply system, we may look at the reservoir levels. If we look at the wastewater system, we may look at the influent or effluent from the wastewater treatment plant. If we're looking at the environment, we may be interested in flow and water quality in the river. But in any case, what the performance in my head means is measuring the state of the system. And why is that important? Because all our decisions around adaptation and where we want to go should, in my opinion, depend on the desirable state. So what do we want? What do we want from our environment? What do we want from our infrastructure systems? And are these two things compatible? So from the measuring perspective, the Nella Meadows says the least obvious part of the system, its function or purpose, is often the most crucial determinant of the system's behavior. So how do we measure the system performance? So when I started thinking about water in systems, then my first thought was, well, we have to model it all. We started looking into integrated water systems models, and we started looking into models which have the physical representation, because if you don't have the physical representation in your model, it's very difficult to represent the physical interventions, which are the most frequent interventions that we do in managing water systems. And we couldn't find any. We couldn't find any model that has water supply and wastewater and the use and the environment and the flow and the water quality. So what happened then, that was 2019, I got a brilliant postdoc and a brilliant PhD student, and we sit together and I told them what I think we need, and they managed to find a way to implement that computationally. So the result of that is a water systems integration modeling framework. It's the open source tool. It's the tool that we have been developing since 2019. And all the results I'm going to show today are the results of that tool. And I'm going to show in the next slide a bit more about the model. So what the model does is it brings back together the components of the water system, it puts all the input in, and then it simulates the performance. We are particularly interested, and you will see most of the results today are the results on the outlet of a catchment. Catchment is a spatial unit where the water naturally flows towards. Why is it a very useful location where we model our systems, or where we look at the results from our modeling, is because this is where all the upstream impacts are captured, and this is also where most of the measurements in reality are, so we can then use those measurements to compare them with our simulations. And another thing that is, again, very, very important is that we do look at the flow, at the water quality indicators at the same time. Why is that important? Because very often, lots of decisions in water management are done based on the flow indicators only. But again, it really hides a very different picture if you take the pollution in account as well. And then, of course, we have the model, we can simulate time series, and then we have to do one more step. So what we do is then take this time series and we produce the indicators or the metric. And in this case, I will be talking about one of the possible metrics, which is the systems level resilience indicators. Okay, so what is WSI mod? Some people call it WISMOD, which we really like. It wasn't our original idea, but it sounds very, very Harry Potter, I think. It looks like this. So these boxes are different components of the water system. So if I now add this high-level categorization that I showed you at the beginning, you will see now that within the water supply system, we have the reservoirs and we have the network. Within the land system, we can have rural land, we can have urban land, we can have the Niband, we can have the drainage network. If we go to the wastewater system, we have our treatment plants. And then if we go into the environmental system, we have the connected system between the river and the groundwater. So each of these boxes has a model behind that. So every component has its own simulation model. What is the beauty of the tool, which Barney and Leon, who did the coding, did, is the integration framework behind the model, which enables fundamentally any component to talk to any other component, which gives us immense flexibility in representing any water system, firstly, and secondly, representing not only physical flows, water flows from high pressure to low pressure, but we can also represent any management and policy decision. So if I say I want to take the water only if the flow in the river is less than X meter cubic per second, I can represent that in the model, which for those who work on water systems modeling is not the usual thing that is represented in the models that have physical representation of the component. This is the QR code. So if you scan the code, it will take you to the paper that actually is the paper about the code. So we have published lots of work in which we did the proof of concept, the different case studies with the WSI mod, but we also published a paper that was peer-reviewed by software engineers, the software developers, which was quite exciting. It's an open source tool, so it's publicly available if anyone wants to have a look and play with it. Okay, so once we have the model, what we do with the model then is to calculate the resilience of the integrated water system. And we use the performance-based definition. So for us, the resilience means that if we have a system performance, and any indicator could be here, so flow, water quality, and so on, we define two levels. So we define the vulnerable threshold and the critical threshold. And these are the values which will be different for different components of the water system. Sometimes they could be defined by policy, sometimes other choices of the operators. And what this defines us is this red part of the diagram, which defines how the system reacts under the change. How quickly goes below the threshold, does it go below first or second threshold, how quickly it recovers. And if we have the performance-based assessment and certain rules for calculating resilience, we can then scale that now into the measure from 0 to 1 for all components of the water system. And what we do with that, we calculate resilience at 3 levels. So we calculate the event-based resilience. So this is one event. These events can happen n times during the year. So we calculate also the annual level. And we also combine them so we can give different weights to different subsystems, and then we can calculate systems level resilience. And in the results, and this will be the last part, I'm going to show you some of the results. We look at 8 different components of the system. So from the supply side, we look at the demand and groundwater resources, and these words in bold are those that are linked to the results. So you can follow them later on. Then from the wastewater side, we look at the pollution from the combined sewer overflows, and we look at the sewer flooding, so the amount of water the drainage system cannot accept. And from the river perspective, so this is this outlet of our catchment, we look at the high flows, which is our proxy for flooding. It's not flooding, it's a potential risk of flooding because it's just a high flow. We look at the low flows, which is the indicator of the risk to drought, and we look at 2 key indicators for the water quality, which are phosphate and nitrate. And finally, some diagrams. This is our case study. So this work has been done on the Luton catchment in North London. And you can see here, it's a relatively small catchment, primarily urbanized, but it has the rural part. It has the wastewater treatment plant, and what you see here are the results from the 3 key data set. Again, we are using some other in the assessment, but the top one is the simulation of the flow. The middle one is nitrate, and the last one is phosphate. And as I mentioned, it's a daily simulation. It's 8 years of simulation. It's a daily simulation. And we use the publicly available Environment Agency data on the flow and the water quality to do the performance assessment. And net cliff efficiency, if people are aware of that, usually 0.6 and higher would be requirable. We were quite happy with that. PB stands for percentage bias. The challenge with the water quality is a bit on the data side, because the data are normally monthly, but sometimes much more rare. So we have much less information to validate our models. But we do validate them before we do any further analysis. And then I'm going to show you some of the results from this resilience assessment. And bear in mind that we can look at this resilience with a different metric. So from the event base, we can look at 4 things. So we can look at the response, and we can look at the robustness of an event. And of course, top right is good. So high is good. High robustness and high response is good. And if we look at these 8 different components, we see quite big variability. So these are all events within 8-year simulation period that came below the vulnerable threshold. Okay? And you can see the difference in the number of events, and of course the difference how they are scattered across this metric. And I'm just going to zoom in to a couple of those. So if we look at just from the perspective of robustness and response, if we look at the low flows and the phosphate, actually the system looks quite good. So lots of events, they do happen, but they go very low, bit below the vulnerability boundary, and they deteriorate very slowly and recover really quickly. So these are good events. Then if we look at pollution, especially nitrate, a bit phosphorus, but much more nitrate, we see lots of dots in this bottom, from your side right corner, where we do see that there is a significant loss of functionality. So these are really the peaks, so those events that go very deep into the vulnerability and critical part, which are very challenging for the system. And then you also see the components of the system, such as flood. These are high flows in the river, which have the mixed performance. So they have the events that recover relatively quickly, but they also have this top left corner, which is the kind of most critical one, where you have these very critical events which recover really quickly. And these are the most critical events in the whole setup. But I guess from the adaptation perspective, these are all very different types of responses. So the question is, how do we go about that? Then on the event base, we can look at other different indicators. We can look how long the disruption is and how percentage-wise the duration is. We call it rapidity. And then we see now pattern emerging, and this is that the pollution type of indicators normally are much more critical for us than infrastructure indicators. So here we see the high percentage of events which are, below the threshold event for the high flows and nitrate and phosphate. We also see some extreme events. So this is the isolated extreme groundwater drought, so very long period of very, very low groundwater levels, which lasted more than 300 days. And we see the pollution events which have a very, very long duration. We can also look at the reliability, which is the very often measure and the metric which we use, for example, if we do flood analysis, frequency of events. We looked at from the perspective of dry and wet, because again, these are two extremes that we are interested in water management, in dry and wet period. And again, this is where the pattern keeps repeating. So we see frequent flooding issues and issues with high pollution concentrations, but we also see very unusual flooding events during the dry season. So the system that is really stressed during certain periods of the year for events that theoretically shouldn't be happening during that period. And then once we have all the events-based metric, we can put it together. So we can calculate annual metrics. So this is the annual resilience in 2019. We can go year by year. And we can look at different components of the system within all 4 event-based indicators. And again, the pattern here keeps repeating. So we see this is nitrate, the dashed line here phosphate, and then the groundwater resources being critical across multiple resilience measures at the annual level. And then we can finally integrate everything. And during the 8 years of our simulation period, when we combine and compare the metric, which is really nice and something very neat that Leon did in his work, we can see what I sometimes call the winners and the losers. So the systems that are designed with resilience in mind, which are infrastructure systems, so systems around, so low flows are protected by policy, high flows are protected by flood measures, sewer systems are designed to be resilient, combined sewer overflows up to a certain level designed to be resilient. Our demand is designed to be satisfied, but the price of all of that is the river water quality. And we see that evidence over and over again. So the question then is, what do we do? And this is where I'm going to finish the slides with just the presentation with just few recommendations around the sustaining. And I must say this work, so with this work, what we did is just to try to understand where we are starting with. So it's the baseline. You need to know where you are starting to know what you want, okay? So if we know what the baseline is, then we can start discussing what we want. And if we have the whole system in mind, then we definitely want good water quality. Again, you know, I've chosen this news because rowing is very close to my heart. You know, water quality is not only for the resources, it's not only for ecology, it's for the people who really use and enjoy being in the water, by the water. And I would argue that the water quality and environmental indicators have to be the starting point. They can't be something that we try to improve. They have to be the starting point from which we see how much we can develop and what needs to be changed in the infrastructure system. Then the second one is that, of course, I am an engineer and I want to be pragmatic. So the point is that we don't develop. I mean, the easiest way for me would be to say, okay, just don't develop and we'll be fine. But of course we want and we need development, and we do want to keep the resilience metric for the infrastructure part of the system as high as it is. So then the question comes not maybe if we should be developing, I think much more how we should be developing. And I would argue that we do know a lot of solutions. So we know about the water efficiency and reuse for many, many years. We know about the nature-based solutions for many, many years. There is a lot of opportunities to look maybe in the solutions which come more from the coordination operational perspective. So especially in the integrated water system where we can coordinate obstructions, for example, and discharges or any other operational control. But I would argue that in the individual systems, we do know the solutions. The question is, are they implemented? But again, this is, I think, beyond engineering. But what is maybe still missing is how everything comes together. And I will use here this document as another warm recommendation for reading. This is much more recent. I have started working with the Institution for Environmental Sciences, and they have produced this really amazing document which is the recommendations for the priorities for the new government. It has a lot of different recommendations in that document. I have chosen this one, which is really, of course, close to what we do, and we are fully supportive, which is that the evidence for decisions that are made from now on, decisions around the planning, which we have many of those plans which are currently produced, the decisions around the policy reform, which is possibly imminent from the perspective of abstraction licenses, but also regulation of the water quality, really need to have the integrated view. And I would argue that with this modeling, we are a step closer to having that quantitative evidence. So my final message is, again, the kind of something that, if you remember one thing, this is it, that I really believe that we do have solutions for the individual water system, but to begin resilience planning of the integrated water systems, we have to use the evidence that captures the interactions between different components. And then we go into something, again, which is not my area of expertise, but it's really interesting to me, which is the decision-making process. And I think the future development and water management will require a lot of compromises from citizens, from government, from organizations, from developers and everyone, if we want to continue living in a world that's relatively good for life. So with this, thank you very much.
Anna, thank you. I'll give you a moment. Anna, thank you so much. I think we so often talk about, systems thinking and the importance of systems thinking in engineering. And I think, the example of your research is so powerful, as if anyone in this room or online indeed needed to be convinced of the importance. I think it's a really good example. I find myself being equally astonished and impressed, astonished that we didn't have, integrated water system model previously, and impressed that you and your team have been able to develop just such a tool. We've now got an opportunity, sort of 10 minutes or so, for some questions from the audience. We've got an audience in the room, we've got the audience online. In the usual way, I will turn to the audience in the room first for any questions. Please don't be shy. Thank you, Raymond.
Raymond Hutchinson, Member of Council. You mentioned about precipitation as one of the factors. What about, with the increasing temperatures we're getting now, evaporation? How does that work in?
Yeah, no, this is, maybe I should have been more precise. It's any climatic input that is changing. So precipitation is really important because it will affect, as you say, evapotranspiration. And in case of significant, for example, land use change, that may be a really important factor. Normally, precipitation has more impact because it's a key input to the system, but definitely evaporation is a really important flux, and yeah, we are simulating that in the model.
Thank you, Raymond. Have you got a microphone coming?
My name is Trevor Cave. Have you got any modelling of the effect of leakage in the mains and of the need for better metering throughout the system?
So the model has the representation of the water distribution system. So I should maybe explain, and I think this comes back to the question why there wasn't a model to do the integrated water system. Because if you do the integration, what you need to sacrifice is a certain level of detail of representing the processes so that you can link them. And what we did there is to start with we don't like to call it simple because it's not simple at all. We call it reduced complexity modeling, which means that we are representing the different subsystems in the least complex way that keeps the physical behavior. So the water distribution systems have the parameter that represents the leakage, so we can vary the leakage in the model. We haven't done analysis around the sensitivity around that, but it's a really good point because significant leakage can influence the supply system a lot, so which means that additional obstructions may be happening, and this is one of the ways to manage the system as well. So for us, any change in the component or link is a potential intervention.
I'll send you some stuff I've done on modelling that question about 10 years ago. You might find it useful.
Thank you very much indeed. That is what we are all about, after all, sharing knowledge, networking with a view to innovating too. I'm not seeing any questions coming in from our online audience, but there's plenty of questions in the room. So I'm just, quick nudge, online audience. Yeah, we're waiting. You'll have your turn. In the meantime, let's turn back to questions in the room. Thank you.
Hi, Darren Sharp. You mentioned phosphates and nitrates. They're now starting to look like they're becoming semi-forever chemicals in our system. Are you now backing into challenges with farming and industry, and how are you facing off on those challenges, and what's the compounded impact that you're starting to see from those chemicals?
Yeah, that's a really good question. So what we can also do with the model is we can do what is called the source apportionment. So we can track back where, at least what the model says, where the pollution is coming from. And the nitrate normally comes from the kind of agriculture sector and so on. The phosphate normally from the wastewater treatment, although of course there is a mixture. So what we have done theoretically is to track back the pollution and assign the measures depending on the source, and of course it has a much bigger efficiency. We have we've been working with the Environment Agency for quite a few years now. They have shown a great interest in the data for the Environment Agency as a regulator. Reasons for not achieving good status are really important. They currently don't use models for that, really. So we are hoping that maybe something like this could support their evidence and maybe help them target the interventions a bit better than they do now.
Thank you. So no competition, but we've got some really interesting questions coming in online now. So I'm going to turn to online in the tiniest font. So, Anna, can the model indicate the beneficial effects from the implementation of nature-based solutions? And that is a question, thank you, coming in from Damien Crilly.
Well, the short answer is yes, because what we can do in the model, and I think this comes to the way how the model is set up, the model really sees the functionality of the system. So for us, nature-based solutions are the solutions that change the functionality of the system. So if you have something which is completely impervious, of course, if you change it with something pervious, such as rain garden, swale, and so on, it will change the properties of the system. If we want to implement, say, regenerative farming, we can change in the model the properties of the soil to represent that. We can add green roofs and so on and so on. So at the function, so we can't do a detailed modeling in a sense. Do we need infiltration trench in front of the institution? We can't do that, but we can tell you at this catchment where this building is, what would be required level of the nature-based solutions to manage, for example, high flows or pollution that is in this system.
Thank you. I'm going to take one more online because they've responded so well, and then I'm going to come back to the room. So the next question comes from Daniel Fantoni, who asks, how do you handle unexpected circumstances in a model? For example, when there is a dramatic excess or tragic lack of water in a system?
Well, the model is tracking the water and pollution balance, so we cannot lose water. So yeah, any extreme high event will calculate in very high indicators of the high flows, which is indication for a potential flooding event. If the flows are really low, that will be shown in the performance of the supply system. So we can see where the reservoirs are getting empty and where the system is stressed because of the lack of supply. We have, I mean, I haven't showed that here, but we have done a range of different scenarios around the development, around the climate change. We are now looking into adaptive planning, which is something really, really interesting, how to deal with the future uncertainties, because of course we can validate models historically. We have pretty, very high level uncertainty around what is going to happen, especially as we go a bit further in time. So we are looking at the ways of reducing that uncertainty by doing the 5-year, for example, planning, rather than going 50 years with a very high level of uncertainty.
I suppose it's reassuring that the model can take account of those extremes, not least because that is indeed the way we see our environment changing. Thank you to our online audience. I'm going to come back to the room because there were very many hands up in the room. I can see, I'll take Peter because I can see that Becca's very close there, and then I'll come to the back of the room.
Hello, thanks for a very good lecture. Peter Flynn, past president of the institution. Have you thought at all about the behaviour of customers, whether they're domestic or industrial, and the impact it might have on the system overall? And is it a game-changing thing, or is it a secondary effect?
So we did. So if you, maybe we should have left the diagram around the model. So one of the nodes, one of the components in the model is a demand, where we can represent the water use in a very simple way. We can say everyone is using 150 liters per person per day, or we can substitute that with a very complex demand modeling. And we have done that work a couple of years ago. We've done the modeling of the change in the water use during COVID, because what happened during COVID, of course, we were in the lockdown, and if you're in a lockdown, you spend much more time at home, and the water use patterns when you're at home are quite different than when you are at work, and also your location is different. So we combined the demand use patterns with the commuting patterns to see what's the difference between the normal water use and the water use during COVID, and we see the change. So we see this change in the signal, and where this change would normally be not so much on the supply side, because the water resources regions are quite big, but the changes will be, at least what we've seen, is on the wastewater side, because if you use more water in one region, you'll produce more wastewater in that region. And London has, I mean, Graham Castleman is here from Thames. London has 9 wastewater treatment plants. There wasn't a significant impact, but we did see, especially for those wastewater treatment plants that are close to tributaries, which have much less water than Thames. But generally, demand management is a very powerful intervention. It's also very difficult because no one wants to go there. The modeling will show you what should be ideal level of water use. I think what is really, really challenging is how to get to enough people to change their behavior and get to that level of water use.
Thank you. And finally, right to the back, James.
Thank you very much. Thank you very much for a fantastic lecture, very interesting. I'm just interested in what's next and whether you can replicate this model, because Luton's quite a small catchment, it's quite densely populated, it's not that rural, it's not that far from me. And just interested, could you apply that model to other catchments? If you get the data, how can you scale this?
Yeah, that's a really good question. So we have done this modeling for quite a few regions in England and then some in Wales. For the model, apart from the water resources data, which are not publicly available, all other data that go into the model are open source and publicly available. So theoretically, not theoretically, practically, we can set up the model anywhere in England and possibly with some challenges anywhere in Wales for now. So what we are hoping, and I guess what is next, is setting up the model for at least whole of England. I think this is something that would be very appreciated from the policy perspective, because they would like to have this big picture view. Hopefully maybe the whole UK eventually. It's just a matter, so it's not a technical issue, it's just a question of data. But I think long term, what we're also looking at are the different global data sets, because the model is so flexible that it can represent any water system. So I would say UK first and then the world.
Fantastic. That's a very, very positive note to end on. Apologies, there were more questions coming in online, and I know there were more questions in the room as well. I do hope, Anna, that you may be able to stay with us for a little while afterwards, so I hope there's an opportunity there, at least for people in the room, to follow up with Anna. Anna, at this point in proceedings, it is customary at IMechE to introduce someone to offer a vote of thanks. And I'm delighted to be able to invite Vinesh Thiruchelvam up to the lectern. Vinesh is our relatively recently appointed chair of the International Strategy Board. Vinesh, over to you.
Thank you, Alice, and a very descriptive presentation, very unique towards what is our ritual and our customary James Clayton Lecture. Thank you for that. From one professor to another professor, welcome to the unique intellectual club. We party in a different way. We work with numbers, as you have seen on your screen here. For my days with Atkins in the industry and having moved into academia, I've always been an advocate for climate change and solutions towards the impact of climate change. And what you have shown today is a very deep insight into a very important, vital area of water. Sustainable Development Goals, you have SDG 6, where it deals with water and clean water and sanitation. I think people around the world have a lack of education and awareness on how important water is beyond just drinkable water and other usages. I think what you have shown is a very detailed manner of how data is being used to clearly show how important the resilience is going to impact in a positive way. But what I've also seen is the data that you've used for measurement. And I think data is a vital area where you extract and how you use the data, because data is a gold lake or a gold mine, if you want to call it, and how you're doing the extraction, remote sensing and stuff like that, and how you're using the data in terms of the algorithms that you build and the models that you develop to showcase that there is a real importance towards the outcome. I think that's very important, and that's what you've shown today. Data is essential, and you have done a very good job in showing that towards your integrated water systems, your Receive mod, if I can say it correctly. I think tools like that will help communities because it's freeware, it's open to the public. I have also worked on a few things I would like to share with you later on. It's my passion, climate change and the impact and solutions. I think emerging technologies will have a very strong impact towards providing solutions, and I think a lot of the data that you have shown gives us an awareness. So again, thank you, Dr. Anna Mijic, for your time today, and on behalf of IMechE, we are grateful for what you have showcased. Thank you very much. And everyone, please give her a round of applause.
Thank you very much indeed, Anna, and thank you, Vinesh. So I'm delighted this evening, dear guests, that we are able to offer not one presentation, but indeed a further presentation this evening. A somewhat shorter presentation, but there will be an opportunity for questions at the end. So if you were feeling denied earlier, then you need to be, quick on the button, as it were, after we've heard our second presentation. So I'm delighted to introduce Francis Heil. Francis is an Associate Director in Climate Change and Resilience at Atkins Realis and part of the executive team of the London Climate Ready Partnership, LCRP. I think we're going to hear a little bit more about them later too. Prior to this, Francis was the lead for resilience and environment at the UK National Infrastructure Commission. He is a climate resilience expert advisor for the Mayor of London's Climate Resilience Review, City of Edinburgh Council, the Asian Development Bank, the European Investment Bank, the British Red Cross, and most recently to the IMechE. Francis, please do join the stage.
Thank you. Thanks, Alice. So we've heard a lot about resilient water systems, so hopefully my presentation builds nicely on that. I'm going to be talking about climate adaptation and just a bit of a snapshot of some of the work happening in London and explain the London Climate Ready Partnership, which I'm here representing. So I'm sure everybody in the room is well aware of this, but climate adaptation, I'll just quickly give a brief introduction to that. So climate adaptation is really about strengthening our systems, strengthening our infrastructure, and building resilience in communities so that we prepare for climate change and we can take opportunities coming out of climate change and reduce the negative impacts. It's separate from climate mitigation, which is all about reducing carbon emissions and reaching net zero. But of course, the two have to happen hand in hand. So just to clarify on climate adaptation. You've already heard about me, so I'll skip that one. Question firstly is, how is climate change affecting London? So on the screen here, you can see a whole lot of climate events that have occurred since the year 2000. And in particular, you'll see since in the last 10 years, a more frequent heatwave events. The heat waves are becoming far more common, but many other events are becoming very common too. So we've had pretty extensive and significant impacts. You can see a picture here of flooding in Hackney Wick, and the impacts of drought in London as well. Both have very significant economic impacts. So really the climate is changing and has already changed, as I've outlined. And there's some organisations who are taking action to this. Some organisations are even yet to begin, but it's really important that we see more action being taken. The inconvenient news is the world is currently on track for 3 degrees of warming by the year 2100, which would deliver catastrophic climate change. So really, there's no question about the urgency of adapting to climate change and building resilience, particularly focusing on addressing the most vulnerable, the people who are most vulnerable to the impacts of climate change, just hand in hand as we urgently address net zero and the need to reduce carbon emissions. So what is London doing about this, and what are organisations around London doing about this? The London Climate Ready Partnership is an example of a partnership across organisations that are coming together to work and commit to working together and share knowledge and best practice to drive climate adaptation across London. So you can see here, this is just an example or a sample of the members in the partnership. I work for Atkins Realis as an Associate Director, and that's one of the members, but we have members from right across academia, the public sector, insurance, the Met Office, and wider. So the London Climate Ready Partnership is hosted by the Greater London Authority, and the Mayor of London contributes a small operational budget and part-time resources to run the partnership. And the partnership's been in existence since the year 2001, so a very long time, and it's changed in form and size over that time. We used to be called the London Climate Change Partnership. We've recently changed to London Climate Ready, just to be emphasising that it's all about resilience and being prepared and ready, rather than climate change, which is broader and touches on mitigation as well. So we really focus on climate resilience and adaptation. So what we do is we host events to bring partners together and share best practice about adaptation. And we have a monthly newsletter to over 250 people across London, which highlights adaptation news and events and research. And if you would like to be added to that mailing list, then please email the email address on the slide here. So, something that's been quite high profile about climate adaptation and resilience in the last year has occurred in London. So historically, climate adaptation has really been lower down the pecking order or less of a priority compared to mitigation. And there's been less public awareness and less focus on adaptation. This has really meant that over a period of decade, the UK has gone from being quite a leader in climate adaptation and climate risk assessments to what many would call kind of middle of the road. That's a few political reasons around that, and I can talk about that later, but more so, I wanted to focus on what the leadership in this arena has been. So the Mayor of London, for example, has shown leadership because after very high profile and costly climate-related events in London, the Mayor decided we need an independent review to consider what are the key actions needed across London and across organisations to change policies, change mindsets, change culture, change built systems, and deliver climate adaptation. So the independent review was chaired by Emma Howard-Boyd, and the review looked at 4 different focus areas of governance, communities, built environment, and economy. I've been an expert advisor to the review since the start of the review, which was mid last year, and we're very pleased to have published the review in July this year after a little bit of a break because of the election. The review delivered 50 recommendations. 25 of these went to the Mayor of London, 19 went to the UK government, and 15 to local authorities. There's a bit of an overlap in some of those numbers because recommendations went to multiple organisations, and there were other organisations named as well, including the London Climate Ready Partnership. So we were specifically called out as a partnership for what we can do to help deliver action on climate adaptation. And it's acknowledged that the Mayor and the Greater London Authority have to really engage with communities, the private sector, academia and wider to deliver the actions required. So this is not just about the government or the Mayor taking action, it's about mobilising collective action and incentivising and inspiring collective action. So I'm going to point out just some of the key recommendations that came from the review, specifically the ones that called out the role of the London Climate Ready Partnership. So the first one is kind of an overarching top-level one. We need a vision for a climate-resilient London. What does a prosperous, inclusive, climate-ready London look like? And this also means, when you get down to more detail, what are the targets we want to aim for? What's the standards of resilience that people should be able to expect for their transport systems to run, for their water supply to be providing clean water? But even things like what sort of access to green space do people deserve? What sort of climate resilient world do we want to live in? And then if we've got a vision for a climate resilient London, we then need a delivery plan. How do we deliver this climate resilience, climate adaptation around London? So that's the second recommendation, a plan to deliver. The third one down is kind of a subset of that, but it's a specific focus on heat, because the impacts of heat waves and heat have been very underappreciated for a long time. There's been focus on drought, there's been focus on flooding, but heat has been the silent killer for a long period of time, unfortunately. And now that we're quantifying this more, that's becoming more evident. I think a stat I showed on an earlier slide said the heat wave in 2022 saw greater than 3,000 excess deaths in the UK. This is really substantial, far greater than flooding obviously causes. So we need a strategic plan for heat. And what that means is not just how does the NHS respond when people flood to emergency response when they've been affected by heat waves. That's the last line of defence. And unfortunately, the NHS is picking up far too much of the slack. What we need is a strategic plan for how we're adapting our buildings, our infrastructure, our environment, our neighbourhoods to be more resilient, and especially in London and cities like London where we have an urban heat island effect. The next recommendation down is about climate working groups, and this means across sectors, we need sectors to come together and think about what do their sectors need to do. So that's, the agriculture sector, the finance sector, the water sector, other sectors. We need them to come together to think what are the actions that need to be undertaken in your sector, and talk to other sectors, because you rely on other sectors and other sectors rely on you. So it's really about bringing stakeholders together and developing joint plans. And then the final one is about delivering more evidence around the costs and benefits of adaptation in London, so that we can take action where it's best directed and we can achieve multiple benefits, like really deliver the most benefit if we're adapting. This shouldn't all just be about cost. In fact, it is actually about benefits, because adapting will cost money in the short term, but it saves so much in the long term. And we can also deliver so many benefits by doing this properly, doing it well in the first place. So those are some of the key recommendations that the London Climate Resilience Climate Ready Partnership has been called out to help deliver. And the review recognised that what we can do here is we can help convene stakeholders and lead collaboration across sectors and across organisations. We can support the collective definition of roles and responsibilities. It's quite a murky landscape, that there's lots of organisations responsible, there's lots of action that many people and organisations need to take. So we need to collectively come together to define what are our roles and responsibilities, what role will you be playing, and will others be playing their part as well? So it's about showing collective action. And then the last part is with the expertise within the Climate Ready Partnership and the different organisations, we can help advise on the scope and the approach to delivering some of the recommendations. We can advise on the potential targets, the data sources and evidence that can feed into these targets, and also about transboundary risks, so risks beyond London and risks like cascading risks that affect multiple systems, multiple infrastructure sectors, or multiple other sectors of the economy. So that gives you a brief snapshot of the London Climate Ready Partnership and our role, our future role going forward, in how we want to help deliver the recommendations from the Mayor of London's Climate Resilience Review. I'm now just going to finish with a case study on we've talked a lot about what needs to be done, but I want to share what some organisations are doing, is showing leadership in actually taking action on this already. And I'll say leadership because, so this is a case study about London Borough of Hammersmith and Fulham. They've commissioned my team at Atkins Realis to undertake a climate risk assessment and help them develop an adaptation strategy. And they're doing this not because it's a requirement of local authorities yet, although that was a recommendation in the London Climate Resilience Review, the local authorities should do this. They're doing this because they know it's important to their electorate, it's important to the people they care about. So they're showing leadership, and it's coming from their own budget. So it's an example, I think, of this sort of leadership to deliver climate adaptation. So I've kind of just outlined this, but my team last year, we helped put together a climate risk assessment. We looked at climate change projections, so that's looking at the future climate. We looked at GIS mapping. I'll show you some of the results of this. We had lots of collaborative workshops with stakeholders within the council and wider beyond the council, including Thames Water, other infrastructure providers, Network Rail, for example. And we've drafted a climate risk assessment. This year, we're working to help the council develop its adaptation strategy. So we've helped them to, and I'll show you some of the results, help them to prioritise actions across different sectors and look at the costs and benefits of taking action and the avenues they have for funding and financing their actions as well. So the next few slides, there's a lot of data on. I don't expect you to know all the data. It's just sort of to show the process that we've gone through. And this is really indicative of the work we do with other local authorities and organisations as well. So it's how do we assess climate risks and prioritise actions. So the headlines here, I'll go through this quite quickly, but the headlines, as I said, the climate has changed and will continue to change. By the 2050s, and if we look at later in the century, of course, you're going to see even greater changes, but by the 2050s, Hammersmith and Fulham, which proxy London, I could just say in London, we're going to see up to more than 2 degrees warming and more heatwave events. The intensity of rainfall events will increase by around 10% and far more later in the century. Summer rainfall, we've already seen some cases of very high rainfall or storms in summer that have led to surface water flooding. So this is also something that's increasing, but there is uncertainty in climate projections. So in planning adaptation, we want solutions that are adaptive, that can be incremental in some cases, and that, wherever possible, are low regret or no regret. They're going to deliver multiple benefits no matter what we do. That's kind of the main message on this slide. I won't take you through all of the projections. So we looked at the future climate projections, and then we did some mapping to look at how would this affect London Borough of Hammersmith and Fulham. We've looked at flood risk mapping and heat risk mapping. And using data from the Environment Agency and from the Greater London Authority, we've been able to identify housing estates and infrastructure in other cases that are most at risk of flooding and heat waves. Shockingly, perhaps, or just as a number, I suppose, that for surface water flood risk in Hammersmith and Fulham, in a 1 in 30-year storm, that's more than 1,500 properties at flood risk. When it's a 1 in 100-year storm, we're over 2,000 properties facing flood risk. So yeah, this catchment, or this borough, is very affected by surface water flooding and sewer flooding. So by using climate change projections and climate risk mapping, we're then able to take the data, as well as collaborative workshops with stakeholders across the council, to assess the risks across different systems in the council. So the council is responsible for looking after public health and health services, public housing and the residences, homes, infrastructure services, community facilities and services, natural assets and ecology, and businesses and the economy within the borough. So these are the systems that we have on the, or the sectors that we have on the left-hand side. And then across the top of the right-hand side, we have different climate hazards. We focused on these 4 hazards here: heat waves and temperature, surface water flooding and sewer flooding, drought and water scarcity, and high winds and storms, because these were the hazards that were most affecting the borough and probably most affecting London in many cases. The big missing one there is coastal flooding, because the Thames barrier and other defences are supporting this borough, so it's not as big a risk, coastal and river flooding. But what you can see basically is just to show you that climate adaptation requires prioritisation. It means assessing risks across different systems and then prioritising where do you take action. And with the evidence, the data that I showed, and the collaborative stakeholder workshops, we were able to say for the council and the services they manage, risks are greatest from heat waves at the moment and surface water and sewer flooding. Not to say the other risks are not great, but these are the ones that need to be prioritised more so. And you can see the sectors that need to be prioritised as well. So health and public housing were found as 2 really high priority sectors. So what are we doing about all of this? That's the climate risk assessment part, and now we're talking about adaptation. So we've looked at a range of different adaptation options and solutions. Some of these are very low tech, but very important. So it's not always about the most high-tech solution. It very much can be about the most practical and socially acceptable solutions. At the same time, there's also highly engineered, highly digital solutions that are required too. So we've had some collaborative workshops with the council to prioritise and talk about what the barriers are to implementing some of these solutions. We're taking this forward now as well to look at how do you deliver the most benefit, what are the costs of these options, and what are the benefits of these options as well. And then just the final thing to kind of touch on is we're looking at where those solutions are best implemented and what the impact of those solutions will be. So we've modelled and we've mapped sustainable drainage systems or nature-based solutions to surface water flooding, and looked at, under different rainfall projections and under different flood incidents or storms, what would the performance of using nature-based solutions to reduce surface water flooding be? This is just some preliminary findings, and I've rounded off the numbers and things, so it's just a high-level kind of output. But what I can kind of show you is that this is quite a costly thing to do, to implement nature-based solutions right across the borough. We're talking over 40 years of capital costs to implement and operational costs. It's over £700 million to implement these solutions. But the benefits are huge. They far outweigh the costs if you look at the long term and if you factor in things that are not monetized well, so natural capital. Things like the benefit of biodiversity, the benefit of carbon sequestration, the benefit of people going to parks and using parks more often so they improve their mental health, their physical health. The other really big benefit is the benefit to people's property values. So by implementing green solutions, neighbourhoods become more desirable, property values go up. That one's a bit more of a tangible benefit. But all of those benefits, when totaled, far outweigh the costs. It's just that those benefits don't accrue necessarily to the council or to the people that are implementing these solutions. So there is sometimes a mismatch between who pays the costs and who receives the benefits. But of course, the councils are here to serve the public good. And so the council has a big reason to be pushing these sort of nature-based solutions. The one other thing to point out here is that the nature-based solutions, there's a number here on SUD's catchment runoff reduction. What that means is that nature-based solutions can reduce runoff from the rainfall by 64%. So that's great, but it's not everything. There's still remaining runoff. There's still remaining potential flood risk. And so nature-based solutions are crucial, but so are engineered grey solutions as well. So we need both, and that's where the mechanical engineers in the room will probably be very excited to hear more that, pumped solutions, pumped drainage systems, flood mitigation schemes are still required alongside the green solutions. That's kind of some output in London on what that looks like. And then the final thing I just want to touch on is that everyone has a role to play in delivering climate resilience. It's not just up to the council or the government, and we touched on some of that here, including, and engineers have a really key role to play here too in terms of updating standards. Lots of the technical standards that exist use historic climate data. They don't include future climate data. So we're still building things right now which locks in climate risk. That is quite astonishing in 2024 that we haven't yet solved this problem fully. But best practice is think about the future climate and build that in. But there's lots of things that need to be done across different organisations and different bodies that have a role to play, including behaviour change initiatives. This is not just about building more resilience and delivering more infrastructure. It's also about raising awareness, changing mindsets, and so that people follow climate-safe behaviours and do what they can around their own neighbourhood and their own properties to be more climate-safe. And this is where partnerships like the Climate Ready Partnership in London are trying to bring organisations together to promote the collaborative work that's required to drive forward some of these solutions. The last thing to say is that today launch is the start of the campaign for IMechE's Climate Adaptation Conference, which will be occurring next year. I'm really pleased to be on the advisory board for the Climate Adaptation Conference, and the London Climate Ready Partnership is really pleased to be partnering with the IMechE in promoting climate adaptation and driving forward action. So thank you very much, IMechE, for inviting me to speak today and to share more about London Climate Ready Partnership, and really keen to answer any of your questions. Thank you.
I'm minded, Francis, thank you very, very much indeed. Do we have time for one question? Time for one question, right, let's...
Burning question.
Yeah, please. Conscious we're running a few minutes over, so let's keep those questions tight. And Joe, you're just right in front of me, so I'm going to give the mic to you.
That was very interesting. Well done. That's very well presented too. I live in Edinburgh, and I thought I misheard Alice at the beginning. The City of Edinburgh Council. These problems are national, they're international problems. How much Edinburgh have introduced clean buses? In fact, a former president was involved in advising them in clean buses, Terry Spall. These problems, they've got the same problems as you. How much work are you actually doing with the City of Edinburgh Council?
Thanks.
I met the Lord Prevost. I'll go back and tell him. All right? How much are you doing with them?
Yeah, thank you. It's a good question because my whole presentation focused on London, so it's good to widen the love. And yes, so I'm working with the City of Edinburgh Council. I've worked with them for a number of years. We've helped them develop their climate risk assessment, and in the last few months, they've just published their climate adaptation plan in Edinburgh. But the key, and Edinburgh has a different context to London because flooding is even more significant in Edinburgh and can be more significant. And heat waves are not quite as significant in Edinburgh, although that is an emerging issue. So there is a different context, and obviously there's a different policy context in Scotland, where what we're doing now with the council is helping to better quantify the costs and benefits of taking action and where to take action. So undertaking economic analysis, and then we've looked at and we're linking the council with different climate funds and different ways to take forward action, because it's not just the technical solutions, it's also the financial solutions. How can we fund the transition to adaptation? What sort of market solutions or incentives are needed to drive private landowners to take action as well, because councils and governments can't be the ones that are solely implementing all this. We need the private sector, we need landlords, homeowners to also take action. So that's what we're now advising Edinburgh on.
Thank you. I'll tell them about the conference next year as well.
Excellent, Joe. Do spread the word. Francis, thank you so much. I think this is a particularly interesting discussion for our community as an engineering community. I think we probably lean towards the technologies, the net zero technologies that are, leaning towards that mitigation piece more than the adaptation piece. So I'm really delighted that this is really just the beginning of the discussion, and we'll follow up next year. So let's just thank Francis again in the usual way, please. So with that, if we can just go to our final slide, I believe. Final slide? Yeah, excellent. Great. Dates for your diary. Francis very well introduced the conference already earlier. October the 14th and 15th next year. Strategic partnerships are a really key part of the IMechE strategy. So, I won't read out all the list of partners on this slide, but I'm delighted that we've got international partners through VDI, for instance. We've got a number of the other professional engineering institutions in the UK. We have government departments. We have various climate partnerships. So really, really delighted that this is really living that strategy. Our unique strength is our membership, is the skills and expertise in our membership. Please do lean in and get involved if this is a topic that interests you, and please do note the contact details. Robin and Laura will be able to help you with that. And this will also include this lecture next year on the evening of the 14th of October. So do look out for that, please. Now, finally, I've got a piece of breaking news for you. Breaking news. The next Prestige Lecture will be early December. It is likely to be the 3rd or the 11th. We are just going around that circle to find a final clarification. But I can tell you this evening, the focus of that lecture. The lecture will examine how engineers can really design for safety and effectiveness around the variability of humans' performance, and to what extent standards and regulation is possible or necessary on those circumstances. So I'm sure that will be a really thought-provoking evening for many of us. It will comprise a lecture and then a panel, and will be introduced by our past president, Carolyn Griffiths. So please look out for confirmation of that date. And as I say, it will be early in December. With that, I would like to thank you for your attention this evening, wrap up the formal events in the lecture theatre, thank our attendees online very much indeed. This is always the difficult point where we're going to go off and have drinks and food, I'm afraid. There's no better way of putting it. And we will leave you to your evening. And for our guests in the room, I'd be delighted if you're able to join us for continued networking and opportunity to ask questions of our speakers up in the library. Thank you.